A very good morning to all of you. This is Deependra Rastogi from IILM University, Greater Noida, as well as I am a research scholar from Galgotias University, Greater Noida, India. Today I am going to present my recently published article, Multi-Class Classification of Brain Tumor Magnetic Resonance Images Using Multi-Branch Network with Inception Block and 5-fold Cross-Validation Deep Learning Framework. So this is a summary. In the recent time, the surge in interest surrounding deep learning technique has been notable. Basically, the essence of this study revolves around the endeavor to comfort the technical challenges inherent in this domain. In this proposed model for brain tumor classification is totally dependent upon the convolutional neural network. Further, we have used the multi-branch network that give the enriched with the inception block, also incorporating a 5-fold cross-validation methodology. In the comprehensive approach, calibrated and evaluated using the BR35H dataset. This dataset has 395 images for the tumors, 826 images for the gliomas, 822 images related to the meningiomas, and 827 images related to the pituitary tumors. Total research is concentrated on discriminating among 3 types of tumors, including the scenario where no tumor are present. And the outcomes are meticulous against an array of cutting-edge classification models like support vector classifier, decision tree classifier, logistic regressions, and Gaussian nerve base. Overall, the accuracy and the variance is marvelous after the completion this study. The accuracy rate is 99.30%, while the variance is 0.0005 for this classification model. This research is a key contribution like that to explore the convolutional neural network using the multi-branch with the inception block, as well as we have to use the 5-fold algorithm also. To provide the in-depth analysis of the important aspect of this study that influencing the fine-tuning strategy also. With the help of this study, we are propagating the multiple number of the classifiers in there, comparative investigations of the previously published classifier in terms of the brain tumor classification and detection accuracy. These are the key contribution of this study that is as follow. In the BR35 is totally dedicated the realm of the brain tumor database, which has the 2870 MRI slices. These slices are captured 3 distinct categories: meningiomas, pituitary tumors, gliomas. While also it has a tumor-free brain tissue images as well. The tapestry unfolded with the 265 slices purely dedicated to gliomas, 822 the realm of the meningiomas, 395 offering as a tumor-free tissues, and 827 is shining light into the pituitary tumors. In this one, it is the total visualization of these 4 type of BRS35 dataset. This is the glioma tumors, meningioma tumors, pituitary tumors, and then no tumor operations. So for this study, multi-branch network with inception block is totally employed to classify the brain tumors. And multi-branch network with inception block input layers is totally designed to handle images with a size of 224 into 224 into 3. So the operation here, we will have to normalize all the data set, because this data set contains a multiple dimensions sizes of the images, like 512 into 512, 236 into 236 as well. The first operation, we will have to convert all these images into the 224 into 224 dimension, because the multi-branch network is totally work on 224 into 224 into 3 dimensions operation. So for this purpose we have used the min-max normalization technique, and that will be followed with this equation. X normalized is equal to x minus x min divided by x max minus x min. Here overall data set is divided into a two operation, training set as well as validation set. So GLOMA 661, training set 165, the valid set, and total 826. So overall this is the distribution of the training set and validation set for the multiple number of the tumors. And this is the graph distribution operation with the help of the label operation like GLOMA, meningioma, no tumor, pituitary tumor. So I have divided these two things. The overall data set divided into the two things, training set and the validation set. This operation is divided into 80 and 20 operation. 80% is the training data set and 20% is the validation set. So before starting the image processing operation, the thing is very understandable like that. The multi-class classification operation with the help of the multi-branch network is totally depicted under the RGB value, red, green and blue. Then this is the visualization of the GLOMA, meningioma, pituitary and the no pituitary operation in terms of the RGB. So in the all over data set we have find out the 20309 is a 512 into 512 dimension set, and 223 246. This is the distribution. Unique counter plot is that how many images in which dimension. So firstly we will have to convert all the images into the 224 into 224. Then we will move on to our next operation. After the converting these images into the 224 into 224 into 3 dimension, we will crop the images. That what is the importance of the cropping the images, and what is the advantages? Basically, if you are cropping, then you will improve the overall composition. We will concentrate on a single topic. Visual information remove too much visual information has been removed, and we will only concentrate on the reframing. We will concentration on the reframing on the topic. Orient of the object differently. Aspect ratio can be changed. So now after that, the multi-branch network with inception block model architecture. This is the overall architecture. In the every step you will see we have performed the vectorization operation for the input value. This input value and then vectorization. Then again for the next layer, this is also an input value. Then we will perform the vectorization, and for every inception block we will perform the vectorization for the operation. And at last we will find out the GLOMA, meningioma, pituitary tumor and like that. So now we will understand how to work in the exception block and a partitioning operation and the multi-branch network as well model. So in the inception block we have the 4 parallel branches. This one, the 4 parallel branches. The first 3 branches collected the data from the input on various aspects in the various dimensions as well. The 4th layer, 3 into 3 max pool, that is the padding 1, is totally perform the channel operation, channel transformation operation, channel transition operation. Then use the 1-to-1 convolution operation here. And after these 4 things, 4 branches, that will be concatenate for the next layer, next exception block. In the partition of the multi-branch network with inception block, in this figure you will understand about the convolution layer, then max pool, then convolution, then max pool. And in the second block you will see there are the 9 inception block with the 2 max pool operation. These max pool stages job to subsampling the input that is travel into the next stage of the network. That means the first one 3 into 3, then this is the 5 instruction block, then again max pool, then again 2 instruction block. After that the average pool operation will be performed. This average pool perform the reduction of the input size, as well as you have the dropout layer, that is a 40% operation. Dropout erased is a 40% operation, and the last layer is the softmax layer. This softmax layer to perform some activation functions. With the help of these activation functions, you can perform the vectorization operation on every layer. So this is the overall multi-branch network model. For this we have some hyperparameters that is used into the our model specifications. In the hyperparameter stage, there is the learning rate. It is 0.001. Batch size we have used the 8. Number of epochs we have used the 50s. Dropout rate 0.5. Kernel size 1 into 1, 3 into 10, 5 into 5. And in the max pooling 2D with the 3 into 3 size, strike 2 and the padding is the same. We have used the IILM and the softmax for the activation function, and optimization algorithm we have used the ADAM. So this is our overall the model architecture for the working. In this operation, initial the input is the glioma tumor, meningioma, pituitary and node tumor. At the time in the stage of the pre-processing operation, we have the resizing the all the images in terms of the 224 into 224, because the multi-branch network is totally dependent upon the 224 into 224 into 3 operation. And after that we have performed the image cropping operation because of the because of the object specifications. I already told you why we use the image cropping. After that, process data 4 classes. These 4 classes have to use for the k-fold cross validation protocol, and for this cross validation protocol I have used the 5-fold technique. So what happened in this particular overall technique? In this optimization approach, the entire data set divided into the 5 subset part, and every subset part have the two things. 80% is the 80% is our training data set and 20% is our validation data set. And these 5 subset have indexes by the 1, 2, 3, 4 and 5 in the segment. So after the completion this operation, the training data sampling set will be trained by the multi-branch network model with the help of the k-fold cross validation technique. The every 20% will be run with the help of this technique, and the training model has been performed. With our validation operation, we will validate the capacity of the and the accuracy option of the training model, which is created by this k-fold cross validation protocol. After that we will check the model wise performance operation here. So why we use the 5-fold cross validation techniques only? For the reason behind that, the balance, bias and variance operations. The second one is the computational efficiency, the robustness of the 5-fold cross validations, and statistical significance because of the good number of iteration to compute the average and standard deviation of the performance matrices. Widely accepted because of the machine learning community and the deep learning community, that is the acceptance is the widely operations, and because of the numerous benchmarks of this 5-fold cross validation techniques. The trade-off is of the data uses, because we have used the 80% of data for the training and 20% of the validation, and sufficient data for the learning pattern. The pattern is specification, the substantial portion of the data set allowing the model to learn meaningful pattern and relationship with the data. In the 5-fold in the training set still contains, and the last one is the stratification. Because the classification task, the 5-fold cross validation can help ensure each fold maintain the class distribution of the original data set. This is the important aspect for the representative or the folds. So these are some factors that's why we have used the 5-fold cross validation technique in this our model. So performance evaluation matrix. This is another important section where we have to find out our overall operation for this performance. The first one is the accuracy. Also we have used the cross entropy operation and then F1 score in this our methodologies. So for the accuracy, it is totally dependent upon the true negative and true positive operations here. And in the cross entropy operation, for the use of the loss function to have been utilized. There is a slide operations. So the graphical representation and the result. In the graphical representation, we have checked on the fold technique. We have the what is about the loss, what is about the training accuracy, and what is the validation loss, validation, and what is the value of the F1 scores. And this is about the overall model accuracy and F1 score operation. So this is the model accuracy and loss for the fold 1. This is the fold 2 graph and methodologies. This graph is represented the fold 3, and this is the fold 4, fold 5, and this is the overall accuracy and the loss graph. The another important section is the confusion matrix. This confusion matrix basically is developed about for the predicted level and the true level operations. This confusion matrix is showing the tumor specification as per the indexing class 0, 1, 2, 3, 4. These are 4 classes, and what is the value as per the predicted value and as per the true value. So for the fold 1 we have a confusion matrix, for the fold 2 we have a confusion matrix, and fold 4, fold 3, fold 4, fold 5, and this is our overall operation for the confusion matrix. It is a very important aspect in our model is that we have comparison to other classifications techniques like the logistic regression, Gaussian NB, SVC support vector classifier, random forest classifier, decision tree classifier, and this is our model multi-branch network with inception block and the 5-fold cross validation. So all have used the Adam optimizer, and classifier is this one. This is our model, and this is the softmax classifier, and we have find out the accuracy level with the variance level. 99.30% is the highest accuracy compared to all other classifiers, and we have find out the 0.0005 is the variance. So this is the comparison with other deep learning state-of-art models. Here we have find out the CNN plus DWT, and my model has the same value. This one 99.30% and 99.308%. So this is the comparison graph with other deep learning models. So why our model is best, and why to contribute, what is the contribution in the deep learning techniques? These are some factors that contribute our model for the deep learning society. Improved classification accuracy, enhanced generalization, contribution to medical diagnosis, model optimization insights, and the last one is the potential of early detection and treatment. So improved classification accuracy, as I have already showing you, my model showing is the great accuracy compared to other one. And enhanced generalization, with the help of the 5-fold cross validation framework, we will find out the robust evaluation of the performance that will help to reducing the impact of the random data fluctuation. That will mostly this type of fluctuation generate in most of the models. So with the help of the 5 cross validation techniques, we have find out the data fluctuation is low, and it will lead a more reliable estimate model ability to generalize the unseen data. That is not learning, but if you are entering in the different data set into our model, that will provide the great and reliable solution for you. So contribution of the medical diagnosis in the contribution operation in the field of the medical diagnosis operation, the accurately different type of the tumors. The accuracy differentiate the value with other models and accuracy with other different models, how to provide our model give the medical diagnosis operations in the treatment plans. And the model optimization insights, the experimentation and hyperparameter stage is showing you that the contribution of the optimization model performance. The exploration of the hyperparameters such as the learning rate and the dropout rate and the can guide research and better performing model of the similar tasks. So these are some contribution that provided by my model. In conclusion, we have seen that the comprehensive methodology of the multi-class classification of the brain tumor, our approach, sophisticated multi-branch network featuring inception block with a robust 5-fold cross-validation technique in the framework. So the primary object of my model to contribute and enhance the accuracy of the patient care. This is my primary object for my model. So with the help of the 5 cross validations, we have seen that a remarkable comparativeness in and promise of our model to multi-class classification operations. As per the accuracy and F1 scores, we have seen that our model gives the best result to compare by other state-of-art model in the previous years. This is our references that I have used in my research. I have used the 42 references. Thank you very much.